Okay, now let's look at this particular problem. The problem is talking about students in a particular school. Normally, we'll bring two different types of digital devices to the classrooms to take notes. The two digital devices is tablet and laptop. And we found out that 80% of the students will bring in tablet, and the 60% of the students will bring in laptop, and some of them will bring in both. So also 10% of the students will bring neither of them. So if we pick a student randomly from the school, find the probability distribution of X, the number of different type of digital devices he brings to school. Okay, so let's see how to solve these problems. Normally for the probability problem, the first thing is that we can just try to draw out a Venn diagram to better visualize what happens here. So let's say this is our sample space. We have a event A, which is the students will bring the tablet into the classroom, which is equals to 0.8. Okay, now let's have a event B, which is the student will bring the laptop into the classroom, which is 0.6. And we also know that there are 10% of the students who will bring neither. So basically, that 10% is corresponding to the purple areas here. Basically, it's all outside the event A and event B. So this purple area, the probability is 0.1. So now the question is asking us, the distribution of random variable X is the number of different types of the digital devices that students bring in. So basically, there are three scenarios for X. X can be equals to 0, which means that the students did not bring into any digital devices into the school. And X equals to 1 basically means that students only bring one type of digital devices. It can be either tablet or laptop, but not both. And X equals to 3. X equals to 2, X equals to 2 basically means that the student bring both devices into the classrooms. So let's see how to solve these problems. So first we know that the probability of A is equals to 0.8. Probability of B is equals to 0.6. And we know that this purple area is 0.1. This purple area, basically, we can use the complement rule. So this is the entire sample space minus the probability of A union B. So A union B is this particular area. And the complement of A union B basically is the purple area, which is represent the student bring neither laptop nor tablet into the university. So we know that this quantity is equal to 0.1. So we know that the probability of A union B is equals to 0.9. And we can also know that probability of A union B is equals to probability of A plus probability of B minus probability of A intersect with B. Hence, we can get, we know that this is 0.9, and we know this is 0.8, we know this is 0.6, so we will be able to know the probability of A intersect with B is equals to 0.8 plus 0.6 minus 0.9, then equals to 0.5. Hence, we get the probability of A intersect with B is equals to 0.5. So now let's look at how to solve this random variable. So for probability of X equals to 0, basically means that the student bring in zero number of devices, basically it means that it brings neither. So basically it's equivalent to this formula here. So basically is 1 minus probability of A union B is equal to 0.1. So this when x equals to 0. So when x equals to 1, basically means that the student only bring in one devices, which is the probability of A union B minus the probability of A intersect with B. So you will see A union B is this green areas, and we want to minus the red area here, which represent the students bringing both, and then the result will be the students only bringing one devices. So here we will know that the answer would be A union with B, we have already calculated is 0.9. And A intersect with B, we also calculate is 0.5. Hence, it's 0.4 for x equals to 1. So now let's look at the last condition, x equals to 2. Which is the red area that just now I draw out here. Basically represent the student bringing both devices. So we can already calculated this, so we can just directly get it, which is 0.5. Okay, so we have calculate the probability distribution of x equals to 0, 1, 2. And you will also notice that if we sum them together, 0.1, 0.4, and 0.5, it is equal to 1. Basically, this means that the total probability of them is equals to 1. That's all for this particular question. If you have any questions, you can leave any comments to me. Thank you.